Hi, Assalamualaikum. Welcome back to my channel, Physics from 5 KSSM. We continue 2.6 Bernoulli's Principle Part 2. In this video, I will discuss on communicate about application of Bernoulli's Principle in daily life. I will also discuss on formative practice 2.6 and extra exercise. The first application of Bernoulli's Principle in daily life is Bunsen burner. Before that, I hope you still remember what is stated by Bernoulli's Principle and also Newton's third law of motion. Let's recall what we have discussed before. Bernoulli's Principle states that in the region where speed of fluid is higher, pressure is lower, or vice versa. And then for Newton's third law states that for every action force, there will be reaction force, same magnitude, but in opposite direction. So we are going to apply these two concepts in order to explain application of Bernoulli's Principle. For Bunsen burner, you look at the structure. There is a narrow outlet here. When the gas supply passes through the narrow outlet, the speed of the gas is very high. So how to explain how the flame is produced? Once the speed of gas here is higher, it will create low pressure region here. When inside here become low pressure region, there is an air hole. Thus the air outside will get into the Bunsen burner, mix with the gas and produce flame. So we can explain by using Bernoulli's Principle. High speed gas move out through the jet to produce low pressure region. High atmospheric pressure from the outside push the air to enter the hole. Air mixed with the gas to produce a complete combustion, that is blue flame. So this is how the Bunsen burner works. The second one is racing car. If you look at the spoiler here, the shape of the spoiler is aerofoil shape, but it is inverted aerofoil. How does the shape help the racing car to travel at high speed? We can also explain by using Bernoulli's Principle. Air moves high speed below the spoiler because of the shape. The spoiler is inverted aerofoil. Low pressure below and high pressure above the spoiler. Low pressure below and high pressure above the spoiler produce difference in pressure. Thus, it produces resultant force F downwards. So the resultant force downwards will avoid the car from lifted when moved at high speed, or we can say increase stability of the racing car. That one is about the aeroflame. We have discussed about the forces that act on aeroplane. You look at the wing of the aeroplane, the cross-sectional area shows aerofoil-shaped wing. We can explain by using this diagram. This is aerofoil-shaped wing. Above the aerofoil part, it is more curved. Thus, it produces high speed of air. At the bottom part, less curved, thus produce low velocity of air. According to Bernoulli's Principle, the higher air velocity at the top section produces region of low pressure. So here is region of low pressure. While the lower part of the aerofoil, air velocity at the bottom one, produces region of high pressure. So there is a difference in pressure between above and below of aerofoil. The difference in pressure produces lift force acting upwards on the aeroplane. Once the lift force produced is large enough, it is able to lift up the heavy aeroplane. Okay, next one is the curveball. For the curveball, you can look at this video. How can the footballer kick the ball and produce curveball? The curveball actually is due to the spinning ball. When kicking, the footballer produces spinning ball. Look at this video. Okay, you watch carefully what happens to the ball. You can see the direction of the ball is not in a straight line. It curves and gets into the goal. So this one we call it curve ball. How to explain this situation? Okay, you can watch the second video. This one will explain how curve ball is produced. Okay, the footballer kicked the ball, so you can see what happened to the ball. It does not move in a straight line, but curve. So we can look at again Newton's first law of motion, which states that the object will continue motion in a straight line if no external force acts on it. If no external force, the ball is traveling in a straight line. But why curve? The ball curve means suddenly it produces a force that changes direction of the ball while traveling in a straight line. Thus, it becomes curved direction. Okay, so this one is due to the spinning ball. The ball spins while traveling. So when traveling like this, let's say this one is anti-clockwise direction. So anti-clockwise, on the right side, it produces high pressure, left side is low pressure. So this one creates a net force that acts on the ball, so it becomes curved. This one we call it Magnus Effect. So at what speed the footballer should kick the ball, the speed does not need to be higher or does not be too small in order to produce the spinning ball. At accurate speed of ball, the ball spin, thus it will create curved ball. So this one also can be applied in other games, for example, tennis ball, baseball, or frisbee. So once it produces spinning ball, it will produce difference in pressure and produce resultant force that change direction of the ball as the ball traveling. So this one will cause the ball to curve. Look at this picture. So this is the ball, spinning ball. Let's say the ball spin in clockwise direction. At the bottom part here, direction of the ball moving same as the direction of air. Thus, the speed of air at the bottom here becomes higher. According to Bernoulli's principle, high speed, low pressure. So at the bottom here, low pressure. Above part, direction of the ball spin is opposite to direction of air. Thus, it will slow down the speed of air here. According to Bernoulli's principle, low speed, high pressure. So it will create high pressure here and low pressure here. This one will result in net force downward. So when the ball is traveling or spin in this direction, the ball, if no spinning ball, it will travel in a straight line to the right. But now there is a force act downward. So this one will produce resultant force on the ball that cause the ball to curve and produce this path of ball traveling. So this is how spinning ball will become curved ball. So you also can explain this situation. The bottom side of the ball has high velocity, okay, because both airstream combine as the flow of airstream is the same direction of the spin. The top side low velocity because airstream combine with opposite direction. According to Bernoulli's principle, the region with high velocity produces low pressure. So the bottom of the ball has low pressure. There is difference in pressure will produce resultant force. So this makes the ball changing its path in a curved path. So this one also known as Magnus Effect. So we apply actually is no longer Newton's first law of motion, because actually when the ball is kicked by the footballer, the ball should travel in a straight line, but then it becomes curved because there is external force produced along the way. So the ball curves and gets into the goal. Okay, the last one is a paper airplane. How can you create a paper airplane that's able to travel further and able to fly longer time in air before drop on the ground? So the concept here is also same, Bernoulli's principle. So we need to apply the concept of Bernoulli's principle when we create the shape or the pattern for the airplane. The airplane is also known as a glider. A glider is a special kind of aircraft that has no engine. In flight, a glider has 3 forces acting on it as compared to the 4 forces that act on a powered aircraft. I hope you know what is a glider. Both types of aircraft are subjected to forces of lift, drag, and weight. Same thing as a paper airplane. When you throw it in air, you are applying force, then it becomes a forward force for the paper airplane to travel. At the same time, there will be drag. Okay? If the lift produced able to support weights, it will stay longer time in air. Okay? Another factor is aerodynamic shape of the airplane, paper airplane. So this one will result in motion of the objects through the air, which reduces air resistance. So there are so many shapes or creative design for this paper airplane. You can look at here. So you can try to produce the shape, and you can maybe you can carry out activity to check the time taken for the paper airplane to stay in air and drop on the ground. Okay. Okay, this one is sailboat. Sailboat consists of board, this is sail, and the boat. Okay, how to explain this one? If you look at carefully, the person, when trying to move the sailboat, they need to pull the sail to the left to produce curve at the sail. So this situation. So when air flow here, at this part B, air will flow at high speed, thus create low pressure region. A, low speed of air, thus high pressure region. Okay, so speed of air stream at A is smaller than B. Air pressure at point A and B, we can compare it. So air pressure at point A is higher than at point B. Thus, it produces difference in pressure between A and B, which produces net force F. So what happens to the sailboat? The sailboat will move in the direction X. Okay, now look at formative practice 2.6. Question number 1, state Bernoulli's principle. Bernoulli's principle states that when the velocity of the flow of fluid increases, the pressure in the fluid decreases, or vice versa. Okay, so just need to memorize what is stated by Bernoulli's principle. Number 2, explain 3 ways of using piece of A4 paper to demonstrate Bernoulli's principle. You can use the first activity like this. What you do, you just blow below the paper to create lower pressure below the paper. A force downward push the paper down due to difference in pressure. B, blow air above the paper. Lift force is produced and lift the paper up. C, blow air between 2 pieces of papers. Resultant force produced push the papers closer. So these are the activities that can be used to demonstrate Bernoulli's principle. Figure 3 shows cross-section of wing of an aeroplane when aeroplane is accelerating along the runway and when it begins to take off from the runway. So you can see this is accelerating along the runway, and this one is taking off. You still remember there is a angle of attack when the lift force enough act on the plane. So we can just sketch again. Okay, with the aid of level diagram, explain how lift force is produced when aeroplane takes off. So this is level diagram. So you can draw above aerofoil, stream of air. This is a region of airflow high velocity, creates low pressure. At the bottom part, region of airflow low velocity, creates region of high pressure. Okay, and then this diagram showing angle of attack. So at this angle of attack, it will exert force on the wing and produce larger lift force that able to lift the weight of the aeroplane. So the aeroplane able to take off. Okay, so the shape of aerofoil causes air to flow at high velocity above upper section of wing of aircraft, at lower velocity below lower section of the wing of aircraft. According to Bernoulli's principle, above the upper section of wing is a region of low pressure, below region of high pressure. Difference in pressure produces resultant force upward or lift the aircraft into the air. The wing is inclined to produce angle of attack. The flow of air below the wing experiences action force and is deflected. The wing experiences reaction force that contributes to the lift force, meaning when inclined like this, meaning it will produce extra force added to the lift force instead of the wing of the airplane. Okay, so this one able to produce larger lift force that able to lift up the heavy airplane. Let's look at one example. This is from paper 2, section C, number 11. Diagram 9.6 shows a sailboat. So you can see this is sailboat, there's board and sail. Okay, you are required to give some suggestion to design a sailboat which can travel faster. Using the knowledge on motion, forces and properties of material, explain suggestion based on the following aspect: the surface of board, the shape of the board, material used for the board, material used for the sail, the size of the sail. So you can see there are 5 aspects listed here. So I think if given 5 aspects, so I think it's easier for you all to write the answer. Sometimes they just give you 3 aspects, so you need to find 5 suggestions. Okay, for 10 marks, there must be minimum of 5 suggestions. Okay, look at the sample of answer. Okay, for the board, the first one, the surface of the board must be smooth, so to reduce resistance. You must write this way like a table form, but in your answer, you must write fully the aspect, and then what is the suggestion for the aspect, and also write down the explanation. Okay. The second one, the shape of the boat is streamlined to reduce water resistance. The third one, material of the board is low density. You also can write a strong material. It's made of composite. It's made of glass fiber. Just take one of suggestion. So if you write down material of the board is low density, so you can write explanation: the board can float easily, or the board is lighter. If you write down the material of the board is strong material, you can write the board not easily broken. It can withstand higher force. Okay. The fourth one, material of the sail is waterproof or made of strong material. So you can write the explanation: the sail does not absorb water and become heavier. So the sail lasts longer, not easily tear. Okay. Suggestion, the last one, the size of the sail is large. Explanation: to produce larger force, because force is equals to difference in pressure multiply area. The larger the area, the larger the force produced. So that's all the topic for 2.6 Bernoulli's principle. So you can search more on this topic so that you can understand better. Okay, thank you for watching. Bye.